Good morning. So today, well, one, it's Monday, but that's okay. Two, today's our 10th lesson of Unit 1, and it's called Differential Heating of Substances. So for yesterday, what we discussed was the different types of heat transfer methods that we have. We had conduction, we had convection, and we also had radiation. Today we're going to take that to the next level and see what happens once that heat is transferred to whatever its destination is. The best example is to go back to looking at the beach. In our case, if you think about the sun as our main source of heat, we have electromagnetic waves that are coming from the sun and are used to heat both the water and the land. Now, the type of heat transfer that is radiation. Again, remember that radiation is the transfer of heat through those electromagnetic waves that come from the sun, from lights, and from things like that. As the energy comes down to the water and to the land, it's the same energy no matter where it's going. It's the same intensity, it's the same amount. But what dictates how hot things feel, how warm they get, how long it takes, is what we call the specific heat. So the specific heat, in short, is how much it takes to get hot. So it's how much energy is required to heat 1 gram of a substance by 1 degree Celsius. Sorry, I got something in my eye. So the specific heat, one more time, is how much energy it takes as heat to warm 1 gram of anything by 1 degree Celsius. That means that the higher the specific heat we have, the more heat and energy it takes to warm something. And the lower the specific heat, the quicker and faster things are going to heat. So higher specific heat, more time, more energy to heat. Lower specific heat, lower time, less energy to heat. Now the application that we best see this in is, again, going back to the beach. That energy hits things. If you go from the sand to the water, which one is normally going to be cooler? The water. If you've ever gone to the beach in the morning, the sand feels good, it's nice, it's cool, but throughout the day, it's steaming hot. You have to wear your sandals, you're going to burn your feet. The energy from the sun heats the land very, very quickly because of its low specific heat. But the water will stay cold because there's a high specific heat. Now what's important about all of this is how it dictates the weather. So because the water can absorb so much more heat without changing its surrounding area, without changing its temperature, coastal areas generally have more mild weather. So that's going to be colder springs and summers, but hotter winters. So it's very much that in-between of the seasons. Rather than the further inland you go, so here you see that we have 110, 115 degree springs and summers, and we also have those 17, 15, 10 degree winters. The closer you get to the coast, to this area here, the more those are going to level out and be closer to each other. And you see that a lot in areas like California or in areas like Oregon or Washington. You don't see as many extremes in temperature. In fact, you just see something that's very much the same. Now today is the second to last set of notes before we enter the exam. So make sure you're looking over everything, make your flashcards, and prepare for the exam this week.